Hello, welcome to another episode of our series where we recreate the classic game of columns using SpriteKit. And today I'm going to implement scoring. So in our board tests file, create a section called scoring. And I'll start with a nice and simple test that says that a new board has a 0 score. So we need a board, and we want to assert that the board score is 0. This doesn't compile because we don't have a score yet, but if we go into our board, we can add a variable called score and set it to 0. So this should now compile. So the error is gone. All tests should pass. So all the tests succeed. So let's continue. Now let's have an actual score. So when a match is found, score increases. And I'll create a board. I'll make sure that the board has some gems that form a match. Then I'll update the board. And then we assert that the updated board score is larger than the original board's score. And this test should fail. So we need to implement something that increases the actual score. So let's see how we can do this. For now, let's see, we have matches found here. That's if the matches count is larger than 0. What if we just say that if matches are found, we increase the score by 1 for the updated board. This should at least be the minimum we need to do to pass this test. Now what I will do is a small refactor. I'll take this one out into a separate function. I'll call this one private mutating func update a score. And we'll say if matches.count. We'll update the score. And we can call this function above. And the test should still pass. Okay, so we're able to increase a score by 1 once you have a match. I don't think that's interesting enough. What I would like to do is reward you for making larger matches. So I want the amount of points you get to be dependent on how many gems you get a match with. So let's start with a case for a match of 4 gives more score than a match of 3. So we need a board 1, And this can be very similar to this board. But then we also need a second board. We'll have an updated board 1 and 2. And then we assert that the updated board 2 score is larger than the updated board 1.score. So let's run the tests. And this fails because we are simply counting how many times we had the match instead of how many gems are involved in the match. So the simplest way of implementing this would be to increase the score. Where is my update score? Right here is to update the score not by a fixed value, but by taking the number of matches. And then we don't need this one either. So let's run this again. And now the test passes. What I also want to reward is that if you remove some gems by making a match, others might start falling and make a follow-up match, and I'll call that a combo, and I want to reward making a larger and larger change of combos. So, and that's not something we have yet, so let's create a test that says something about the combo. So again, I need a board. However, this board will have 2 matches on it. I will update the board. Then we need a second board. And we need to construct this board a bit specifically. So let's see. So we can start at 0, 1 with a blue. Then we need a red one and another blue one. And we need another blue one, but this time on a different row. We need another red one. And we need a green one. And another green one. And then another red one. This will make the reds have a diagonal match first, then the reds disappear, and then one of the blues falls down and then makes another match. It's still 6 gems that get removed in the end, 6 here as well, but I still want to say that the updated boards score is larger than the updated boards 1's score. Now I see what is wrong. to get this to work, you need to call update twice, because this one in the first update removes the red ones and the second one removes the blue ones. So let's see what happens. So now they have the same value, and I would want the second one to have a larger value. So what I'm going to do is I'm going to keep track of a combo multiplier. And I'll start it at 1. And each time we'll multiply with the combo multiplier. And we'll add 5. So I wanted to ramp up quite fast. So now this test should pass. Okay, cool. However, what I also want to make sure is that after the combo finishes, and that's when you spawn a new column, then the combo multiplier should reset. So after a combo finishes, the combo multiplier is 0, 1. Yeah. So we need a board, and I can more or less use this one again. Oh, I don't need the one even, so it's just one board. I'll take an updated board. I'll update it a couple of times, and then I'll assert that the board.combo multiplier is 1. We'll assert that the updated board's combo multiplier is 1. But it's a lot larger than that, so we need to reset the combo multiplier at some point in time. And we'll do that where we spawn new gems. Here we'll set it back to 1 again. Okay, this now passes. And let's see, and finally I want to make sure that the combo multiplier only increases if there are actual matches. So when there's just a set of gems falling, for instance after a new set of gems was spawned, then the combo multiplier should stay the same. So I'll create a test for the combo multiplier does not increase when no matches are found. Then I'll need a board. I'll create a couple of gems that can fall. And I'll make sure that these don't lead to a match. I'll update the board. One update should be enough. I'll update it again. And then I'll assert that the updated board against combo multiplier is the same as the updated board's combo multiplier. And this one fails, but we can fix that if we only increase the combo multiplier. is actually positive. And now the test passes. So we have all the logic in place to do scoring. Now let's make sure we get it also in our game view. So let's go to our game scene and let's add another published variable called score. Let's see, where we do the update, we update the state, but we'll also update score. And where we reset the game, we also reset the score. So this should be enough in terms of the game scene. And now let's go into our content view and find a place to put this thing. Let's see. Let's run. Let's see what this looks like. Okay, so we have a score here. It's currently 3 because we immediately spawned a set of gems that were a direct match. So let's see if we can make another one to see a bit better what happens. Oh, well, we could use this one, for instance. So we see the score increase. Let's see if we can make a combo, and that's always a bit tricky. But who knows? Maybe that's possible, or we'll just stumble upon one if we play the game for a bit by just making some random choices. If I can get rid of the green one there, I should have a combo. So I need one more green. I'll put the green here. Now we have a combo, and you see the score increase quite a bit. So I assume this is working. And the thing I do notice is that, okay, so we have scores increasing, we have combos. I do think the UI is getting very cluttered currently. So there's these buttons that are obscuring your play field. There's this score thing just hanging around here, and we need more UI elements to indicate levels, to indicate the next set of gems that will be falling. So we need to improve this, and that's what we'll do next time. Next time I want to start implementing gesture control. So you won't be pressing the buttons for left and right and for cycling, but you can swipe left, swipe right, and tap the screen to do control the actual gems. So that's it for this time. Thanks for watching and have a great day.